Al Gore Climate 101 video replication number 5. In this experiment we'll be doing something just a little different. As you can see here we've got our familiar globes from the previous experiments, but I have thermistors on them with cables. Those go over to this electronic data logger connected up to my computer network through this cable right here, and of course the probes are connected through these wires. I have 3 probes. Probe A, or number 1, which is color-coded green, which will go into jar A, and then the next one, which is color-coded red, goes into jar B, and then a third one, which is the ambient air temperature just hanging in the air here, which is color-coded yellow. So there's no confusion about where they're connected. And double check the connections. And then over here on my computer I have the data being displayed live from these different devices. Let me put this into macro so you can see it. You can see here probe A and B, the green and the red are very close to one another, and then we have the ambient air, which is a little cooler because it's down a little lower, closer to the floor. Turned off all the air conditioning. We've got starting temperatures here of 78.7 and 78.6. They're within 1/10 of a degree of each other, so we know they're good. Now these are calibrated from the factory, NIST calibration for both probes plus the data logger. So we know them to be accurate and we know them to be linear. And that's important for this experiment. This will be the most accurate representation of the experiment yet. Now, the first thing I'm going to do here is get set up. I need to show you a couple of things. First of all, we have this change here, this ring. We have to put this on because the split right here has to allow for the cable to pass through. Otherwise, the lids won't stay on correctly. And other than that, there's no other real changes here. We've got our other familiar components. So the first thing I'm going to do is establish that both jars have ambient CO2 levels, like we've done before. And that one reads 672, which is higher than, of course, the world ambient level, but you know, we are in an office and we are in a city, so those two things figure in. And here's one, it's a little higher. Not much. I breathed on it, so that probably has something to do with it. So both jars are close to ambient levels. Now what I'm going to do is set up, put this on the tripod, and get jar A set up with the temperature probe. I'm going to put this in, and this is color-coded green for probe number 1 to jar A. Set that down inside of there. Looks like it's centered up well. Make sure that the ring goes there. Make sure everything's set and centered. Now we'll move this and get it centered under the lamp like we've done before in the previous experiments. And this one, move this a little bit, we'll establish that we're inserting CO2 in here. We'll give this a squirt. Okay, you can hear that, I'm sure. Now you can watch the level go up, and it is going up fast. And pretty soon it will be off the scale, since it only goes up to 10,000 parts per million. There it goes. So we know we put CO2 in this jar. Take out the meter. Put the temperature probe in. Color-coded red, notice. Alright, we're going to have to insert CO2 again because some of it may have leaked out. Okay, going to give it another squirt. Whoa, it moved. So much force, we have to move it again. It happens. Too much pressure. Let's try this once again. Okay, didn't move that time. Alright, got this set up. Hammer this under there. Looks good. I believe both jars are properly centered. Okay. Alright, now we're set up for recording. Now, I want to show you what happened. In Mr. Gore's experiment, he did not allow for any settling time. And you notice what happened? I put in the CO2 and the temperature started going down in the red-coated jar, jar B, probe 2. It's at 79.0 versus 80.1 for the ambient air jar. And that's because the temperature went down because when you expand a gas, as we did out of the bottle, the CO2 bottle, it cools. One of the basic gas laws. And there's nothing we can do about that. Mr. Gore didn't provide any settling time in his experiment, didn't indicate any, didn't call for any, didn't ask for any, didn't imply any. He said, just put the CO2 in these two in the one jar and not the other, and start the experiment and away it goes. Now I'm going to provide for a little bit of settling time here to get these closer to one another, and hopefully we'll be able to do a much more accurate experiment, because I don't want the difference in the temperature at the initial starting points to have any effect on this experiment whatsoever. I want to make sure that we start within about 0.1 to 0.2 degrees of each other. Right now we've got a whole degree difference. No, not quite. We've got 9/10 right now. And they'll slowly converge as the temperature of jar B comes up. So we've got 80.3 for jar A and 79.4 for jar B. That's still about a difference of a degree. As you can see here, they are still diverged. By the way, this is humidity scale for our system here. That's not temperature or degrees C. Okay, that's humidity and wetness. But over here we have our thermometer scale. Now I can read the values by moving my mouse over it. And you can see here, I don't know if you can read the data, 79.5 for jar A and 80.4 for jar B. So we have to wait a little bit for settling time, and hopefully we will be able to start the experiment. I apologize for having to do that and make you wait, but science, good science, is not fast. It's all about waiting to get things right and make sure the starting points are the same. So right now I'm reading 79.7 for jar B and 80.5 for jar A. So they're getting a little closer. And when they get close to within about 0.1 or 0.2 degrees, I'll call that close enough to start the experiment. Now I did a couple of test runs to practice setting these up, and I did notice that as soon as you turn the lamps on, the temperature shot up dramatically. So we'll see that happen no matter what, but I want to make sure the starting conditions are as close as they can possibly be. Okay, we've got 79.8 right now. 79.8 in the CO2 jar B and 80.5, 80.6 in jar A, 79.90. So they're getting closer. We're starting to see some convergence here in the data, so that's good. Won't be too much longer now, we hope. One thing I think I will do, just to eliminate any other possibility of bias, and I'm going to turn this just a little bit so that the angle of the two probes matches. I don't think it makes any difference whatsoever. Make sure that's centered again. I don't think it'll make any difference at all, but we do want to make sure everything is exactly the same. Okay, we've got 80 and 80.6 for the two probes. They are getting closer. Takes a while for the temperature to settle, but we have to do it in order to do this experiment right. Of course, you can skip ahead on the video and get to the point where we start the experiment, where you see the lights turn on, and we'll of course watch the data as we go along. You don't have to sit through all this, but I wanted to make sure that I recorded everything exactly as it was being done, with no edits whatsoever. And while that may be boring in terms of video and the production quality might be far less than you might expect, it's not about the production quality or the edits or this jazziness. It's about recording what actually happened during the experiment. Okay, we're at 80.1 and 80.6. We're within a half a degree of each other right now. And they are very, very slowly converging. Well, hopefully it won't be too much longer. Okay, we're at 80.2 and 80.7 now for the two probes. Now within a half a degree of each other. This is in Fahrenheit, by the way. By the way, I've turned off all the air conditioning in the room and the ceiling fan and any other things that might potentially bias the two thermometers in any way, shape, or form so they get identical exposure from the heat lamps. Well, we're getting closer. We're now at 80.2 and 80.6. They are converging. 80.3 and 80.6. Won't be too much longer now, and we'll be able to start the experiment. Move these to the foreground a little bit so that there's no chance that we get any reflection off of the infrared on either one of them. Now we're back to 80.3 and 80.7, so we're still waiting here. And I apologize for this long delay, but we've got no choice but to wait until they get the same. Of course, when I started and we had ambient air and both of the probes are out in the ambient air, they were identical as you saw at the beginning. So we know the probes are matched. The calibration from NIST proves that. No worries there. We know the data logger is properly matched to the probes. That's all part of the calibration process that we get from the factory. But this jar is still just slightly cooler due to the fact that we put some highly expansive gas in there and it cooled quickly. Alright, 80.4 and 80.7. We're 3/10 of a degree separating them. Not much longer now. The resolution of the thermometers is 1/10 of a degree here. So we're almost down to the point where we can call them the same. 80.4 and 80.7. So we're very close to be able to start. Of course, you'll be able to see this in the data. I'll have the data available on the web, and you'll be able to see the starting point when we turn on the lamps, and the time mark and everything will be there. And we're still at 80.4 and 80.7. It takes a long time for the temperature to settle when we get down to these tenths of a degree. 80.5 and 80.7. Okay, we're very close now. I would say probably close enough to start the experiment. 0.2 of a degree probably isn't really anything significant. No, jump back to 80.4. Just noise in the system, I suppose. Well, once it gets back to 80.5, I'll call that good enough. Ah, there it goes. Read my mind. 80.5 and 80.7. I think that's close enough to start the experiment. If the experiment at the end is within 0.2 of a degree of each other, well, we can attribute that to a difference in the starting point. So at this point now, I'm going to turn on the lamps and start the timer. We'll immediately be able to see a rise in temperature. This logs data every 15 seconds, and we'll watch this live. There it goes. Both are going up pretty quick. We have 81.3 and 81.7 within 0.3 of a, oh, now it's up to 82.8 and 82.3. Okay, experiment's on its way. We'll look at it again at the 5-minute mark and see how it goes. In the meantime, I'm going to plug in my AC power supply for the camera so that we don't lose power. Double check the shot and make sure that, there we go, macro's back off. Okay, we're good. Gonna let that sit now for a while. We'll check it again at the 5-minute mark. See what we can see in terms of difference. Okay, we're 5 minutes into the experiment. Let's have a look at the video. There we go. We're at the 5-minute mark. And let's see what the differences are. Remember, green is the ambient air, and red is the one with the enhanced CO2 jar. Well, look at that. We have a divergence going on. They went from being from 0.2 of a degree separating each other to almost half a degree so far. Or more than that. Let's take a look up here at the numbers. 98.7, 99.7. So we got a whole degree separating the two right now, 5 minutes into the experiment. So that's a good result so far. We'll see how it goes as we go further into the experiment. We'll check again at the 10-minute mark. Okay, we're at the 20-minute mark, past the 20-minute mark. Let's take a look at the temperatures again. And as you can see, we go from the start point, the divergence occurs, and it seems to be holding pretty regular. Right now we have 106.7 and 107.5. It's actually come down a little bit from before, but that's fine. Now the experiment, as Mr. Gore represents it, is that the jar with enhanced CO2, which in our case is the red line, would rise faster and higher than the jar with regular air in it. So far, that does not appear to be the case. Okay, we'll put this back on the tripod here and let her go. We've got 17 minutes and 30-some seconds remaining. Okay, we're coming up on the 10-minute mark now. You can see here we're down to 10:08, 10:07, 10:06. Let's take a look at what the data says. Well, we still have our divergence from the starting point, but it seems to have leveled out. Doesn't seem to be any significant gains. They're pretty close together still. And again, the claim of the jar with the elevated CO2, which is the red line, according to Mr. Gore, that jar would rise faster and higher than the one without CO2s. And again, so far, that does not seem to be the case. Now, let's look at the temperature data. 112.5, 113.10. So we're about 0.6 of a degree apart. Account for the difference of the 0.2 of a degree that we started with, and there's about 0.4 of a degree total difference between the two jars. Not much to measure. Certainly not a dramatic result. The way that the experiment was run, it implied that there would be some kind of a dramatic result, but that doesn't seem to be the case, nor does it seem to be matching the claim of jar B would rise faster and higher than jar A. But we'll wait till we get to the end of the experiment and find out. Maybe it just needs a little bit more time. Well, we're less than 4 minutes now to the end of this, and so far there hasn't been any real difference of change in the situation. Both jars are within about a half a degree of each other, as they have been before, so it doesn't look like there's going to be any significant change in rate or values. The curve is starting to get a little bit sloped. The slope is reducing. As you can see here, starting to level off. Right now we're at 115.4 for the probe with elevated CO2 and 116.1. There we go, 115.5 and 116.1. There's not a whole lot of difference, about 0.6 degrees. That seems to have been holding through the whole last several minutes. And we're now down to less than 3 minutes left. At some point we'll establish an equilibrium between the jars where the temperature of the jars will be plateaued. They won't be able to absorb any more heat, and the amount of heat that they're radiating should be balanced. And so we shouldn't see any temperature changes after that. The question is how long it takes to reach that. Don't know. Okay, we're at the 1 minute mark, and the two thermometers are at 116.3 and 116.8 as I read it on the screen at the current time. So only a half a degree difference between them. Not much. Certainly not a dramatic result. Okay, we're down to 30 seconds. I'm going to take this off the tripod so we can watch the last few seconds. Okay. 0. Turn off the lamps. And let's have a look at the data. Very close. Not a whole lot of difference. 116.7 and 117.3. 0.6 degree between the two thermometers. Now we had 0.2 degree difference when we started, so the amount of actual difference isn't hardly anything at all. For all practical purposes, they're almost identical. If it weren't for the extra resolution that we have in this system, you probably wouldn't see any difference at all. That's why we couldn't spot much difference in some of the earlier experiments. And as you can see now, after turning off the lamps, the temperature is headed down. In fact, I'm going to leave the data log a run for a little while and see if we see any difference between the slopes of the two as they drop. Clearly, this needs a lot of input into its system to maintain the temperature, And the moment you turn those lamps off, boom, the temperature starts dropping dramatically. Now we're at 113.8 and 113.8. They're totally identical. 112.7, 112.8. Clearly, the heat lamps and the energy input is key to the experiment having a difference. 111.7, 111.6. So we'll let that go for a little while, and I will do a screen capture of this graph so that we can put it on the blog and you'll be able to see the results, and then we'll tally it up. One last check before I go. We'll just double check here. Go back. It's dropping quickly. So we've got 110.2, 109.8. Now there's some divergence in the drop developing. Oh, this is getting interesting. The jar with the CO2 seems to be dropping ever so slightly slower than the jar that has plain air in it, which would be expected because of the radiative retention properties of CO2. And of course, the air temperature is at 79.7. It came up a little bit. The probe 2 with the CO2 108.5 and 107 now. 107.8. So yeah, we are getting a little divergence in the dropping of the temperature. So certainly we are seeing the radiative effects of CO2, but it's not as Mr. Gore described. It's not on the uptake, it's on the downstroke, which is to be expected. So that's the end of this experiment for now. We'll go have a look at it on the web, on the blog, with the data. Thank you for watching.